Hello to everybody, I'm Marco Beato, Associate Professor in Sport and Exercise Science. Today I want to explain you how to run a linear correlation using JASP. We have this database, and today we will analyze three variables. So we will perform a correlation between contemporary jump baseline and contemporary jump post, and later a correlation between contemporary jump baseline and standing long jump baseline. We suppose obviously there is a good correlation between contemporary jump baseline and post because we have the same subject, they have repeated the baseline test and also the post, and also that there is a good correlation positive between contemporary jump baseline and standing long jump baseline. Why? The motivation of that is because the contemporary jump is a vertical assessment of power and jump capacity, and standing long jump is the horizontal equivalent. So let's start to run our analysis. So you need to go on regression, click here and select correlation. At this point, I suggest you to select this specific option, so display pairways, and select your variable. So in this case, we start with the contemporary jump baseline and contemporary jump post. So as we supposed before, the correlation is very positive. We have a correlation that is significant, so you can see the p-value, and the Pearson R is 0.959. So it means that the correlation is very high, nearly perfect, and we expected that. So how can we improve our analysis? So one thing that I recommend is to select this option, confidence interval, and you can see that we have now here our lower and upper confidence interval at 95%. You can actually modify this specific score if you need to have a correlation at 90%, but usually in sports science we have a confidence interval at 95%. So next stage is to create a scatter plot. And if you click here on scatter plot, you have the correlation in front of you. You will have, in this case, the contemporary jump post on the left, contemporary jump baseline on the horizontal axis. If you want to add the statistic, you can click this option and you will see the software reports for you the R and the confidence interval that are the same values that you have in the correlation reported in the table. So you actually don't need that, but if you want to add that to the figures, you can do that. Another thing that we could add is the confidence intervals in the figure. If you click here, you have now the confidence intervals. Clicking here, you can also increase a bit the size of the picture, and you can see obviously the confidence interval and all the dots that represent your data in this specific figure. After this analysis, I would say we can move to the next one. This is simply the analysis of the contemporary jump baseline with the standing long jump baseline. So I repeated the same procedure and I go on regression, select correlation, and we try to repeat exactly the same analysis. So contemporary jump baseline, standing long jump baseline. Obviously, our assumption is that the correlation is very positive, probably less positive than this one to have just analyzed because obviously the two tests are different, but this one is what we expect. So I select my, I calculated my correlation. We have the same table that I've just reported above, so just to click here on display pairways and add your confidence interval. At this point, you can see that obviously the correlation is high, and we have a significant p-value here, and your confidence interval lower and upper reported on the right of your p-value. However, I want to show you something else. So here, when we decide to use the Pearson correlation, so sample correlation coefficient, that type of analysis was the default analysis. To be actually sure about the analysis we need to do, we should run a assumption check. So correlation, if we wanted to run the Pearson R, should respect the assumption normality. So since our data are pairwise, so the same subject has repeated the same analysis, we need to click on Shapir will test here and see if our data are normally distributed or not. In this case, the Shapir will test show you that the analysis is significant. So actually, our normality assumption is not respected. So we shouldn't use a Pearson R for this analysis. So we should choose a Spearman's row. So if I click here on Spearman row, after we'll remove the Pearson correlation, you will see that the correlation is not actually the same. So it's very important to analyze the data in the right way, because if we analyze this data with the Pearson R, we would have shown a lower correlation than what actually we have with the right Spearman row analysis. So I deselect here the Pearson R, I keep only the Spearman's row, and I have my p-value, Spearman's row that represent the effect size, lower and upper confidence interval, and I have below my assumption check, so normality assumption in this case. To complete the analysis, I select scatter plot, and I want to see also the confidence interval and the statistic. Okay, so as we did before, we can increase a bit the size of the picture, and I can say that the analysis that we aim to do is now run for both the combination of variables that we wanted. So going back here, we have the analysis using a Pearson R. At the contrary, in the picture below, we have the analysis of the Spearman row. So remember, every time when you analyze your data and you want to run a correlation, to evaluate the assumption of normality. Thank you very much for following this online tutorial. I hope you have enjoyed it. And if you have enjoyed it, please register to this YouTube channel. Thank you very much.